Assalamu alaikum. My name is Sumaya Akhtar Rubina. Welcome to my presentation. Today I will be presenting on the topic of CRC technique for error detection and error detection process. So let's dive to the topic. What is error and what are the types of error? So error is a condition where receiver's information does not match the sender's. Digital signals suffer from noise during transmission that can introduce errors in the binary bits traveling from sender to receiver. That means a 0 bit may change to 1 or a 1 bit may change to 0. Two types of error are in there. One is single bit error, which means only one bit in the data unit has changed, and second one is burst error. That means two or more bit in the data unit has changed. These are an example of single bit error and burst bit error. Now I'm gonna explain what is error detection. Error detecting code is to include only enough redundancy to allow the receiver to deduce that an error occurred, but not which error, and I have have it request a retransmission. Error detection uses the concept of frequency, which means adding extra bits for detecting error at the destination. Now question is, what is redundancy? Instead of repeating the entire data stream, a shorter group of bit may be appended to the end of each unit. This technique is called redundancy because extra bits are redundant to the information. They are discarded as soon as accuracy of the transmission has been determined. We can detect errors using these error detection methods: parity check, cyclic redundancy check, and checksum. So simple parity check. Simple parity bit is a simple error detection method that involves adding an extra bit to the data transmission. It works as one is added to the block if it contains an odd number of ones, and 0 is added if it contains an even number of ones. This schema makes the total number of ones even. That's why it is called even parity checking. Two-dimensional parity check. So two-dimensional parity check bits are calculated for each row, which is equivalent to a simple parity check bit. Parity check bit are also calculated for all columns. Then both are sent along with the data. At the receiving end, these are compared with the parity bits calculated on the received data. Checksum error detection. Checksum error detection is a method used to identify errors in transmitted data. The process involves dividing the data into equally sized segment and using one's complement to calculate the sum of these segments. The calculated sum is then sent along with the data to the receiver. At the receiver's end, the same process is repeated, and if all zeros are obtained in the sum, it means that the data is correct. Checksum operation at sender side. Firstly, the data is divided into segment each of m bits on the sender's end. These segments are added using one's complement arithmetic to get the sum. The sum is complemented to get the checksum. The checksum segment is sent along with the data segment. Cyclic redundancy check. Cyclic redundancy check is a popular error detection technique used in digital networks and storage devices to detect accidental changes to raw data. It's widely used because it is efficient, easy to implement in hardware, and very effective at detecting common types of error that may occur in the data transmission. This is CRC generator and checker. In CRC technique, we need a divisor. The divisor is determined according to the algebraic polynomial. A polynomial should be selected according to following rule. One is should not be divisible by x it should be divisible by x1. Here is an example of CRC generator where we divide data by the polynomial. Thanks for your attention.